Good morning, and we are at our sixth Classical Mechanics 1 lecture. Today is 18th of August, Thursday. Yeah, so I would like to first of all appreciate that all of you have submitted your second problem set, and I want to go through a few of those questions briefly. Any questions before I do that?
As it questions related to the problem set, sir, or in general?
Either of them.
Yes, sir. So I would request you, if possible, to discuss the physical intuition of jerk in, I think, the last problem.
Okay.
Where we see that it is in the anti-parallel direction as compared with the tangential velocity. But how is it actually influencing how is it actually influencing acceleration when it's actually perpendicular to it? And I mean, what is its physical significance mainly?
Okay, I think I heard your question. So yeah, if I can make some comments on that, I will do that. Was that Somendra Singh Karola?
Yes, sir.
Okay, fine. Just a moment. Let me share my screen. Okay. Yeah. So I would let me just go through some of these questions briefly. The first one, so I'm discussing Classical Mechanics 1 problem set 2. I hope you can see what I've written. Yeah. So one general comment is that these questions, they have been stated in the problem sheet, and we have, of course, discussed some of the concepts previously in the class. And what is expected is that you would use the concepts you have learned and the statement of the problem to work it out or try to work it out. And the idea is not so much to look up this term or concept somewhere else and use the result from elsewhere. Yes, it is a good thing to look up things elsewhere. However, if you wish to use some result from elsewhere, you would need to derive that result or explain how it's obtained. Yeah, so the idea here is not to look up this concept somewhere else and use those results, because there can be some logical shortcomings in such a procedure. I really would like you to make an effort to answer the questions based on the data provided. Let me elaborate on what I mean. So let's look at the first question, which is to express the Cartesian components of the cross product. So we want the x, y, and z components of the cross product in terms of those of A and B. So many of you have understood and done this nicely. However, there is also some confusion, I think, as to what is expected. So fundamental thing we begin with is, of course, the orthogonal decomposition of A as AX x hat plus AY y hat plus AZ z hat. And a similar formula for B. Let me write that out. Bx x hat plus by y hat.
We are not able to see what you're writing.
Oh, I'm sorry.
If I take IJK, is it okay instead of X?
Yeah. You are welcome to use IJK. I hope you can now see my screen. Thank you for alerting me. Yeah. So you are welcome to use I for X and J for Y and so on. Yeah. Yeah, if you prefer that. Okay, now what we have deduced previously using the setup was that if XYZ are an orthonormal, a right-handed orthonormal system, then they would, for instance, point in the manner I have drawn in the picture. The cross product of X with Y is Z hat. Okay, so, and we can, of course, from this picture also deduce a couple of other formulae. For instance, suppose I take Z and take its cross product with X. Well, what is it?
So Y hat.
Indeed, thank you very much. So Z cross X is Y, and the last one, well, there are several, but the independent ones, let me write one more. Yeah, let me go to Y cross Z hat, and Y cross Z, I think you will agree. I mean, I'm using this right-hand thumb rule. Yeah, so I want to be very clear about the approach followed. We have defined it using the right-hand thumb rule, so that is the tool available to me. Yeah, so this is indeed a property of the basis, Srinish Sinde. Yeah, right. So the three formulae I have written are, of course, once you have the first one, that already sets up the frame, and then the other two you can deduce from the figure. Yeah, yeah, so I mean, yeah, I mean, the first one is definitely a defining property of a right-handed coordinate frame. So it is available to us. Of course, we have anti-symmetry, which means that Y cross X is minus Z hat and so on. Okay, so we have those as well. So I can reverse the order in each of these formulae at the cost of a minus sign. And finally, I have also X cross X hat is, well, what is it? Zero indeed. Yeah. In fact, any vector cross product with itself is zero. Yeah. Because it's anti-symmetric.
Sir, zero vector.
Indeed, you are quite right. This is the zero vector, and I was wrong to omit the sign. Yeah. Okay, so now we have all the basic ingredients, yeah, to compute this cross product of A and B. So let us do that, because that is what was intended. A cross B is going to, I'm going to take this and in general, how many terms are there going to be?
9 terms.
Nine terms, right? Yeah, of course, we are very lucky. Lots of the terms will combine and some will be zero. So our job is not so bad. So let me start with the first one, AX, BX, X cross X, which happily is zero. Yeah, and so all the diagonal terms are all zero because Z cross Z and so on are zero. So diagonal terms are zero. Then you have some of the off diagonal terms. So let me go to the next, AX, BY, X cross Y. That is from these two. And then we've got AY, BZ, Y cross Z. I hope you see how I am proceeding, AY, BZ. And then finally, I have, let me do AZ, BX. Yeah, which would be Z cross X. So I'm taking this with that. So I'm done with the 6 terms so far. And then we've got 3 more left, which should be AX, BZ, X cross Z, plus AY, BX, Y cross X. Okay, just so I know that you are following me, what is the last term that I have not written?
AZBY.
Indeed, AZBY. Thank you so much. Yeah, AZBY. So this pair, I have to include AZBY, and that is Z cross Y. Okay. So this is the expression we have. And now all we need to do is simplify it a little bit So I shall do that here. X cross y is z, y cross z is x, and z cross x is y. Those we have just established, and you will notice a pattern here. There is a cyclic symmetry. Yeah, so it's often nice to write it in a way that reminds us of that cyclic symmetry. Yeah, so if I write this circle, yeah, yeah, so x cross y will give you z, and then y cross z will give you x, and z cross x will give you y. Yeah, so just go around that circle. I mean, that's just a mnemonic device to remember this these three formulae. So I am now almost done. X cross z is minus y. I hope you will agree. X cross z is minus y. And y cross x is minus z, and z cross y is minus x. Yeah. So we now just combine these terms. I want to collect the coefficient of x hat, and that gives me what? The coefficient of x hat is ay bz minus, that is this thing, minus az by. Yeah, so that's this term. I've combined those two. So that's the coefficient of x hat. Then there's the coefficient of y hat. So excuse me for those who figured this out and have answered it well. But I just want to go through this once. And for those who would like to see it. So the coefficient of y is coming from here. A z b x minus ax bz. That's this term. Yeah, so, and finally the coefficient of z, I shall write here, which is from here, ax by minus ay bz. Did I write that correctly? A by bx, I'm sorry. Yeah, so here we are. I invite you to do the same if you have not done it or haven't done it while I'm doing it. And here are the components. So let us summarize the answer. A cross B, the x component thereof is AYBZ minus AZBY. And so on. So I can summarize the rest of them. A cross B, Y component is AZBX minus AXBZ, and finally A cross B Z component is AXBY minus AYBX. All right, so this is the answer that was expected. And this would be a way to deduce it. Any questions so far?
So would it be all right if I didn't expand it like all the way, but I've stated that I cross JSK and all the other parts, and I haven't written it all explicitly as such. Will that be fine? I mean,
Okay.
all the 9 terms, I haven't stated them all. I've
Okay,
just stated that, and by expansion, this is what we get.
This is what we get. I mean, I think you are using, okay, I would appreciate it if you would write one intermediate step.
Yeah, I've written one intermediate step where I distribute terms of A over B individually, but not like each and every term explicitly.
Okay, fine. We will have a look at your answer sheet, but well, this is the first time we are doing it, or perhaps you have done it before. I think it is instructive to write out these terms, and it will be a good idea. You will notice some patterns and learn from the process. Yeah, so yeah, I mean, I would err on the side of writing all the 9 terms in this case and telling me why some are 0, or at least indicating, as I did, something of that sort. I mean, the explanation has to be there, even if it's very brief. What is not advisable? So was that Kaustubh Manda?
Sir,
Okay, so I hope I have addressed your
yes, sir. You.
question. Yeah. Now, I mean, some of you have perhaps from your previous knowledge or other studies, you have taken some formula for A cross B. I mean, I want to, you've written some formula of the following sort. I'll put it in quotation marks. There is something of this sort, X, Y, and Z, and then AX, AY, AZ, BX, BY, BZ, and used this formula in codes to obtain the components. So several of you have done, some of you have done that. Now, well, I mean, at no stage have we said that this is true. I mean, if you are going to use such a formula, you would need to establish it. And the way to establish it is to actually do what I just did. Yeah, so so that's where I would like to be very clear. If you are going to use some such a formula, you need to justify it. You need to go back to first principles and justify it. I am not saying you need to prove distributivity of multiplication or addition. Okay, those basic algebraic operations I am willing to accept, but additional formulae need to be justified. In addition, there are problems with this formula. It is only a way of remembering things. One cannot take this determinant formula very seriously because it is not very meaningful. Operations you perform on a determinant like exchanging rows or columns, I mean, they are not very meaningful. If there is a unit vector sitting here and a real number sitting there, what exactly does that mean? So this is at, I would like to regard this as a mnemonic device for remembering or easily generating or quickly generating the answer. It is not a substitute for deriving the answer. So I make this distinction.
Sir,
Yes,
sir,
please.
one question. Can I, so I have established this formula by going through the first principles,
Okay.
but I have written it like this. I have written it as x cap, I have written, actually I have used I cap and j cap, whatever.
Fine.
But x cap into 1, 0, 0, ax, ay, az, bx, by, bz, can I write it like that?
Yeah, that is a better thing. Yeah, this I am very embarrassed to write this formula. What you are saying sounds a little bit better. Yeah, you have written it in terms of 2 by 2 determinants. Is that correct?
I have not written in terms of 2 by 2 determinants. I have written in terms of 3 by 3 determinants.
Oh.
But instead of writing x cap, I have so x cap into 1, 0, 0, ax, ay, az, bx, by, bz.
Okay.
That's I cap into 0, 1, 0, that x.
Yeah, I see what you're saying. So you are saying something like x cap times 1, 0, 0, ax, ay, az, this sort of thing. Am I right?
Yes, sir.
Okay, yeah, that's a little bit more respectable. But again, if you want to write such a thing, please derive it. I think that is what you have done. Okay, so yeah. I mean, there are determinants in this story, but this determinant is a little bit of a hocus pocus. It is not really determinant. Okay. But feel free to use it to remember the answer, having derived it once. Okay, any other question about this?
Yes, sir. I stopped at the penultimate step, not in the last step. The step above where you have explicitly delineated X, Y, Z. Yeah, I have.
You stopped here.
Yes, sir. I stopped here because it clearly mentions.
Okay, fine. All right, that it's sort of 90% the way. Yeah, if you like your salt in your food in the right levels, then I like my components stated as well. Okay, yeah, but I understand what you say. Yeah, I mean, anyway, we can learn to state the answer. I mean, after there's a specific question, that question needs to be given an answer. So yeah, I would like you to get into the habit of stating the answer, whatever it may be. in as clear a way as possible. As mathematical scientists, we can aspire for that. Okay. Any more questions on this? And for those who did use this determinant expression, it's fine. You may not get all your marks for it, but I hope now you see where this trick comes from. It comes from explicitly working out these expressions, and I hope you will.
Yes, sir. That was my second question. My second question is that can we not say this in terms of volume? Like,
no, not just yet. The volume is coming up, I think, in the next question. Just a moment.
Yeah, I mean the box product. I mean the triple product. That is,
yes.
We can find out the components by the triple product, right? I can multiply. So I can take.
Okay, could you just hold on? Let me write down the second question, and maybe after we do that, your question can be asked once again, because it seems to be very much related to the second question. Please hold on, Ryan Hota. So the second question is to simply show following identity that A dot B cross C is equal to I think I forget which one I chose, C dot A cross B. Yeah, I think that is what I had. Yeah. So okay, before we get into the details, just to address, was that Ryan who asked?
Yes, sir.
Yeah. So yes, before we get into details, first, maybe any of you can tell me what is the interpretation of this identity subject to proving it.
Sir, it is the
is
volume of parallelepiped.
Yeah, the signed volume of this.
parallelepiped?
Yeah, it's about the volume of a parallelepiped, but what property of the volume of the parallelepiped does this convey?
Associativity
Box product.
Associativity.
The volume of the parallelepiped is being represented by this expression.
Right.
So irrespective of how you.
Not a few variables.
Yeah. Anyway, I'm very glad many of you are offering suggestions. So yes, this, let me write it in words. I think that will help. This is the volume of the.
You're looking at the words oriented volume.
Yeah. So yes. So the volume, it is an oriented volume in a sense. That is true. Yeah. So, but let me write it. That will be conveyed in what I write. The volume of the parallelepiped. I hope I got this spelling right. What am I doing? Okay. PARALLE. Anyway, let me not attempt to correct my spelling. Yeah, parallelepiped defined by the three vectors A, B, and C in that order. Yeah. So I would like to state it. I mean, you have used some term oriented volume. Let me convey the same thing in the following manner. The volume of the parallelepiped defined by the three vectors A, B, and C in that order. So what I mean by that is that I A, B, and then C is point some way. Yeah, and I'm supposed to complete the parallelogram and then erect the height as well on top of this. Yeah, and then complete the parallelogram above. Yeah. So yeah, now this volume is given by this expression. I mean, we have not proved that, but I leave that as a something for you to think about. But suppose we accept this, it's not difficult to establish. Then it is stating that this volume can be obtained in two equivalent ways. Either you consider it as defined by A, B, and C, or as defined by C, C, A, and B. Yeah, C, A, and B. And it is saying that those two volumes are the same. Regarding this business about orientation, that does play a role. For instance, it would not be true. This is not equal to C dot B cross A. Okay, in fact, these two are negatives of each other. Yeah, so so in my picture, ABC form a right-handed system. Yeah, ABC form a right-handed system, whereas ACB or CBA form a left-handed system. CBA, C cross B will give you minus A. So as long as the basic vectors you write down in this order both form a system of the same orientation, both right-handed or both left-handed, then the answer is the same. That is what this is conveying. Yeah, or geometrically it is saying it is taking the area of the base and then including several layers to stack it up and computing the volume, either starting with this base or starting with a different face as the base. Okay, so yeah, perhaps I've not been very precise, but is the interpretation roughly conveyed? I'm sorry, I have actually not even written a sentence, which I need to correct. So the volume of the parallelepiped defined by the three vectors A, B, and C in that order is the same as the volume of the parallelepiped defined by the three vectors C, A, and B in that order. So yeah, so that is what this statement is, this identity is conveying. Any question about this? Yeah,
Sir,
yeah.
B dot cross A will also give the same result.
Oh, you're quite right. Yeah, there is a third equality that I could also put over here, which is B dot C cross A. Indeed, you're right. There are three formulae. So thank you for pointing that out, Nirjar. And they're all related by cyclic permutations. That is, when I think of cyclic permutations, if I do cyclic permutations, I will take this A to that place. Yeah, so then it'll become A dot, and then the B will move one spot and C will move another spot. Yeah. B cross C. The dot and cross remain as they were. So that's what I mean by cyclic permutations. Yeah. And then there are three analogous formulae having to do with the left-handed orientation, which are got from this and its two cyclic permutations. Okay, so that is what Nirjar was pointing out. Any other question about this statement?
Sir,
Okay.
is this a research proof?
No, I have not proved anything. I have simply stated something. No, the problem has not yet been answered. I am simply giving some interpretation of the identity proposed. And I have not proved that this expression is equal to the volume. That too I have not done. That you have to do, or I will discuss it another time. Is that what you're asking, Ryan?
Yes, sir. That is
Yeah.
what I'm asking.
Yeah. So no, I am not currently. I have not established this. I am only giving an interpretation. But I claim that establishing it is relatively straightforward. We will do it another time, perhaps, or I invite you to think about it. Okay, and of course, this result I have written it merely as algebraic identity, and now given it some geometric interpretation. This also has physical interpretation, but that to understand that is requires a little bit more background, because this quantity, when appropriately interpreted, has some meaning as some kind of energy, or yeah, so it can yeah, so in rotational motion, such expressions do turn up. Okay, so and it states the equality of two ways of computing some energy.
Could you please tell me how this concept of orientation generalizes to higher dimensions?
Yeah, it is possible to generalize these concepts of orientation to higher dimensions. Yes, yes. So, okay. I mean, for curves, it is clear. I mean, the curve has got an orientation once you put an arrow on it, and this curve is directed this way, whereas it is directed that way if you choose the other one. And for surfaces, we have a similar notion. At least surfaces, in a simplest way, surfaces embedded in 3 dimensions. If you set up some coordinate system x and y, then yeah, you would say you would define the upper side or lower side based on this cross product. Yeah. Now, okay, there are many ways of generalizing these concepts to higher dimensions. I assure you there are many ways to do it. I'm not sure this is the place for me to be doing that. Yeah, let me, I hesitate to do that right now. It will take us a little farther afield. But yeah, there is a very clear concept of orientability of manifolds valid in any dimension. We can do that, and it goes back basically to having coordinate frames and working with them. There is that is one way to do it at least. There are many ways to do this, but I think the language is not yet in our possession here, so I hesitate to do that right now. Sorry about being a bit. Yeah, I mean, the orientation of a surface, if it is consistently specifiable, then if you take a closed curve on that surface and then you say that you have defined some orientation that is upwards, you go around that closed curve, you should return to that same orientation. Yeah. So Shubham Mal has asked, we are entering linear algebra now. Can you name some books on this topic to read it properly? Yeah, I will try to suggest something. Sure. No, this is not really linear algebra. This is combining properties from linear algebra with the theory of multilinear algebra with theory of manifolds. So, okay, when there is an opportunity, we will talk about this more precisely. Yeah, if you like, I am going to define the volume of a parallelepiped specified by these 3 vectors A, B, and C. Yeah, where C is yeah, where they go in this order, A, B followed by C, to be positive. Yeah, whereas if I reverse B, A, and B, you will get a negative answer. Okay, so so that way we can assign positive and negative volumes to parallelepipeds that are defined in different ways. Yeah, I admit I'm being a bit imprecise here, but partly on purpose because it will take us too far afield. Okay. Any other urgent questions on this? Okay, if not, well, as regards the solution of the question posed in the problem sheet, well, that is fairly straightforward. You are simply supposed to take our formula for A cross B and then go and dot it with the third vector and get the answer. So I hope that most of you have done it. I do believe many of you have. But
so can we just say, deducing from the previous result, we just put we don't have to expand the cross product all over again.
No, you can use the result for the cross product. So if you want to, if I understand, Kaustubh, you are referring to this and you're saying from the previous result, I will simply write down B cross C as, what is it? It is some BX CY minus BY CX.
Yes, sir. I just simply wrote that down.
Yeah, you are welcome to do that. You don't need to rederive this. You can certainly use it from the previous study, previous problem. So, but let me write the remaining 2 coefficients. There's the X part, which would be BY CZ minus BZ CY. And then finally, there's the Y part, which is BZ CX minus BX CZ. Yeah. Okay, so you may ask me, how did I write down this formula? Of course, part of it is from memory, just derived it. But how do we go from one term to the other? It is simply by cyclic permutation. So if I want to go from this term to that, X goes to Y, and then Y goes to Z, Z goes to X. So we are just doing that. So you will notice that Y goes to Z, Z goes to X, Z goes to X, and Y goes to Z. Okay, so that's how I wrote down the second expression. And the third expression is again by one more cyclic permutation. Yeah, so that is it. Yeah. So such things will certainly be discussed in a multivariable calculus course, perhaps even the book by Spivak as such things discussed much more carefully. Just to mention one book. I mean, Spivak has several books, but you can select the right one. Okay. Now, so that is the formula for the cross product, and then I want to go and dot that with A, which is AX X hat plus AY Y hat plus AZ Z hat, right? So just want to dot it with that. So you will get an expression for this, which is simply AX times. So now only the diagonal terms will contribute, right? Because X dot Z is 0. Yeah, only X dot X is 1. So only that term needs to be retained. AX times BY CZ minus BZ CY. Then I will have the next one, which is AY times BZCX minus BXCZ. And finally, AZ times the Z component, which was BXCY minus BYCX. Yeah, so this is this A dot B cross C. So I mean, there's a reason I've written it out in all detail. It really doesn't take very long, and I really do encourage you to do it. There is no substitute for that. And doing it by hand is even better. Okay. Yeah. Now, of course, does anybody want to propose a shorthand notation or a nice expression for this whole thing? It turns out that this whole, I mean, this is simply some real number, right? This real number can, in fact,
in terms of a determinant, right?
Indeed, yeah. This now can be expressed in
Yes,
an honest way. In an honest way that I will not be embarrassed to write. It can be expressed as a determinant, and that is the following determinant. It is AX, AY, AZ, BX, BY, BZ, CX, CY, CZ. Okay, so it is that determinant and that this expression is equal to. And I leave it to you to check that. But it is not necessary for this problem for you to observe that this is the determinant. It is fine to work with this, and then similarly compute the other case, which is C dot A cross B by similar means. I will not do it here for lack of time, but I encourage you to compute all the terms and then notice that the terms match with those here after some rearrangement. The terms, and then you will see that the two are equal, and in doing that you would have proved that the determinant has a property. We will in effect be establishing some property of a determinant, yeah, namely that this determinant is also equal to the another determinant where the C's have gone upstairs, and then the A's have come to the.
Sir, one.
Yeah.
Sir, so can I use the determinant? I mean, we are proving that the cyclic permutation of a determinant does not change the value.
Correct.
But can we not use that fact as directly, like from the theory of determinants, to prove this?
Sure, yeah. I mean, if you have, first of all, you have to derive this formula. I don't see any substitute for that. You get this formula, then show that it is a determinant, then use the property of determinants to show that this determinant is equal to that determinant, and then reinterpret this as another
Sir, we can
product.
use the parallel pipe volume. First, we can prove that it is the volume of the parallel pipe made by vectors A, B, and C.
Yes, Satyen, yes. Yeah, I think, okay, I didn't catch the rest of your question. You are interpreting this in terms of the volumes of parallelepipeds. Okay, well, if you want to ask your question again, you can do so.
If the box product is the volume of the parallel pipe, so the volume will come the same irrespective of how we take it. We just need to prove the cyclicity of the right-handed system.
Yeah, you are very right. Yes, yeah. If you are able to establish that this formula for the triple product is in fact the volume of a parallelepiped, and then argue that the volume of the parallelepiped doesn't change under cyclic permutations of the basic three vectors, then yes, you could proceed that way. Sure. Yeah.
One thing, do we need to find out the components of C dot A cross B again? Because we already found a formula like thing, right? Identity maybe. A dot B cross C can be expressed in determinant in this form. So do we need to find the formula of C dot A cross B again? Because
no, you can just relabel the letters and get the formula. Yeah, you don't need to rederive this. However, I do wish to nitpick and say that this does not have components. This is simply a real number. It's not a vector. So I object to the term components of the triple product. I hope I am understood.
It did not say components, but I mean, what to?
Oh, you mean the terms in the expression for this? Am I right?
Sorry, sir. I have forgot. I think I have done. Anyway, please continue.
Yeah. Okay. No. I am just joking. Yeah. So this is just a real number, which is a sum of some 6 real numbers, and yeah, I would not call any of them as components. I can call them summands, or I can call them terms in the expression. Yeah. But the word component is reserved for a component of a vector, at least at this stage. Okay. Yeah. All right. So we have any further question about this little problem? Okay. If not, let us try to go to the next one. Okay. So the third one is about the Levi-Civita symbol. Yeah.
Sir, I think there was some missing information with regards to this.
To this problem. Okay, so let me remind you what information was provided. You are told that there is a symbol epsilon ijk, where ijk take values from 1 to 3. So that is given to you, and you're told that epsilon 1, 2, 3 is equal to 1. That is one property, or one defining property you're given, and you're given one more defining property, that epsilon ijk is minus epsilon jik. Actually, this is only one instance. What was stated is that epsilon reverses sign under any exchange of a pair of indices. So is everybody on the same page? These are the two defining properties given to us. Nothing else is provided, and you're supposed to proceed from here. So let us see what we can do. So, okay, we are asked to compute a few of those examples. Perhaps we can focus on that. I need to remember which ones I gave. So let me copy them down. Epsilon 213, epsilon 312, epsilon 321. Okay, let's do these three first. Yeah. Okay, so here we are. Okay, I emphasize once again that or rather I would like to say that whatever we want can be obtained from just these two conditions. Nothing more is needed. Least of all, looking up Levi-Civita symbols in other books and so on. Yeah, this is really straightforward. By definition, or rather from property 2, exchanging the first pair of indices, I will say that this is minus epsilon 1, 2, 3. Yeah. And then using property 1, this is actually minus 1. Yeah, is that okay?
Yes.
Okay, great. So then the next one is a similar game. I can reverse the first, or what shall I do? Let me reverse the first and third. Yeah, let me reverse the first and third at the cost of a minus sign. I will get 2, 1, 3. But that's what we already computed, and it was minus 1. So this has to be 1. I hope you followed the approach. I exchanged the first and third indices at the cost of a minus sign, and then I used the first result. There are other ways to getting this, of course. There are other ways. I can do it in 2 steps in a different way. I want 3, 1, 2. I will do 2 steps. I can go to minus epsilon 1, 3, 2. Yes, exchange the first pair, and then exchange the second pair. So that will be plus epsilon 1, 2, 3, which is plus 1. So however you wish, you proceed by succession of exchanges, each of which costs you a minus sign.
So can we directly state that all permutations of 1, 2, 3 that have come about by even number of shifts have +1, whereas those with odd number of shifts have -1?
Yeah, correct. Now, the thing is that, see, the statement you made is essentially correct. However, that is a statement that you have asserted. You have not deduced it from properties 1 and 2. That requires 2, 3 lines of explanation. I invite you to do that or not use it. Yeah, so what you have said is entirely correct, but it needs to be deduced from here. Okay, so Kaustubh, are you clear about at least?
Yes, sir.
Yeah, okay. So okay, so see, there may be other ways you want to define your epsilon symbol, but that is for a different place. Here we are working with a certain definition. By the way, this is the standard definition. So everything else is a consequence of this. Let's go to the third one. That is a similar game. I can write it as minus epsilon 1, 2, 3 by exchanging the first and third. Yeah, so now we have become experts at this. That's a minus sign. And then I had 3 more relatively similar ones. I think they were epsilon 1, 1, 2, epsilon 3, 1, 3, and finally epsilon 2, 2, 2. Okay, let us see. This again is you exchange the first 2 indices, you will get minus epsilon 1, 1, 2. Okay, so that is the trick. Yeah. But then what we have concluded is that there is a number which is equal to its own negative. Yeah, so that number has to be 0. Yeah.
How have we concluded that it is a number?
No, it is a real number. Okay, you are saying I did not say that this is a real number.
Yes, sir. That is what I'm saying.
Okay.
Sir, it is mentioned that they are integers in the first line.
In the problem itself, okay, if I have forgotten to mention, I am very sorry about that. No, I really do apologize that I should have said epsilon ijk.
Yes, sir, you have said that ijk are integers.
Yeah, I only said that ijk are integers. I did not say that epsilon is a number. Now, I did say that epsilon 1, 2, 3 is 1. That is a number. Now, the rest of them could be animals. They could be birds. You are quite right. And there I have slipped up. But okay. Anyway, I hope if you feel I have not provided that information, then I do admit a slight deficiency.
Sir, half marks more for everybody.
Well. Let me see.
Yes, sir. Sir, so is it the fact is that after you had given this question, and this is why I had asked you this question last time also. So how can we assume that they are integers? And
no, they are not integers. We are not assuming they are integers. I mean, we are not supposing they are. No, okay. See, look, we are getting a little bit. I think I am humoring you a little bit more than deserved. Okay, at least up to this stage, I think there is no ambiguity. The given information is adequate to find all of these.
Yes, sir. That is
yeah. Now your question comes at this stage. I think at this stage we have established that epsilon 112 at least twice this quantity is 0. Yeah. Now, okay. I have not said that this is a number and maybe your imagination carries you beyond and you want to think that it is something else. Okay.
So,
okay.
sir, one thing which we would like, like in physics, are there some quantities, for example, we cannot add to both sides? Are there? Like, do we need to be careful about things like that? Like, suppose I'm adding epsilon 112 to both sides. Can we do that always? Like, is it?
No. To be meaningful, they have to be objects of the same sort. Otherwise, such operations may not be well defined. Yeah. So I mean, okay, I accept with some humility that I didn't say these are numbers, but I do expect some level of common sense also.
I'm just asking, like, when something is not mentioned, like what parts of that, like we are, like how do we assume something? Like, I'm not saying that we should not assume. I'm saying how do we know what to assume and what not to assume? Like when there's something given.
Okay. Well, there are several things. One, you can ask me, and if I am stupid enough not to understand your question, then ask again, or ask your question a little bit more precisely, more specifically. Then I will understand what you're saying. It's not that bad. Otherwise, if you're not asked me, please do use your common sense, or you make an assumption. I assume this is a number and it's not an animal or it's not a bird. Yeah, you make some assumption, state your assumption, and I will give you credit for that. Yeah. Sorry. Yeah. So, okay. I mean, there are cases where one is working with some modular arithmetic, base 2 or something like that, and therefore you cannot conclude that this is 0. But let us not do that here. We need to use some common sense about the nature of the quantities appearing in our equations at this stage, at least. Anyway, I completely understand your desire for precision. I shall try to meet that requirement. Any further question? See, if something is not said that it's a number, please go ahead and assume it's a real number and see the consequences. If it's a vector, the context should convey things. After all, the next formula itself says I am taking epsilon and multiplying by x hat and y hat and so on. So it is, I think, a little bit of common sense will tell you that these have to be numbers. They cannot be vectors, for instance, because what will it mean just to juxtapose two vectors next to each other? There is no cross product or dot product provided. Okay, so the final, okay, there was this one, epsilon 313, that is equal to minus epsilon 313, exchanging the first and third, and therefore both of them have to be 0. And the final example was epsilon 222, which is minus epsilon 222 if I just exchange the first two, for instance. And that again has to be 0. So this is how one can argue that the last three are 0. And of course, from this, you can deduce some general things, which many of you have done, that epsilon, if a pair of indices coincide, then it is 0. Of course, if three indices coincide, it's again 0. And if ijk is an even permutation of 1, 2, 3, then it is 1. And if it's an odd permutation of 1, 2, 3, it is -1. So these are consequences that we can deduce and then make use of. Any question so far? Yeah. So so I'll now proceed to problem 4. In problem 4, you are asked to show, that. Okay, let me see what I have given you. Okay, this is the scalar triple product A dot B cross C. You're asked to show that it is equal to epsilon ijk ai bj ck, sum over ijk. Yeah. Okay. So let me. Yeah. So I hope from this formula at least it is clear that we are taking a linear combination of such trilinear expressions, and so these things have to be numbers. And we are welcome to work with such a assumption. Okay, now this is a rather quick check. We have already computed this, and we have the expression for it. And I will then we just need to expand this thing out as well, and then compare the two expressions. So for instance, if I write out this expression, what will I get? I will get epsilon, things like epsilon 111, A1, B1, C1. But that is simply 0 because epsilon 111 is 0. So so there are lots of terms with repeated indices. Yeah, so all of them are 0. And then we can specialize to only those where the all indices are distinct. And well, one of those terms is epsilon 1, 2, 3, A1, B2, C3. Yeah, so this one is 1, of course, and so you get this coefficient, this thing. And then I have to write out the remaining ones. By the way, how many terms are there a priori? Total number of terms?
So 27.
27, indeed.
27.
So 3 cubed, 27 terms are there, but we have already thrown out a lot of them which had a pair the same. And so we are left now only with how many terms left beside those?
6.
6, indeed. We got only 6 terms, 3 of which are even permutations, and 3 of which are odd. So we can write those 6 terms. So then there's going to be, let me go to cyclic permutation 3, 1, 2, A3, B1, C2. Yeah, and then I will get epsilon 2, 3, 1, A2, B3, C1, and then finally 3 more which come the other way. So I can start with 1, 3, 2, A1, B3, C2. See, I have not written it in a very careful order. I'm just writing them out. And then epsilon 2, 1, 3, A2, B1, C3. Yeah, and the last term is epsilon 3, 2, 1, A3, B2, C1. Yeah. So now you can observe that all these coefficients are 1. Yeah. And all these coefficients are -1. So and then you replace 1, 2, 3 by x, y, z, and then compare with the previous expression. Okay, so and you will notice that they are the same. So any question about the procedure we have followed?
So how do we state, like what is the proper way to state this? I'm taking those terms to be 0. I am not worrying about them.
Yeah. Oh, sure. So thank you for asking. So so you could say that terms in which at least one pair of indices are the same vanish. Yeah, that is the statement over here, vanish, and therefore may be omitted. Yeah, so I don't know if that is what you asked, but this is one way to say it in words. There are better ways as well. Yeah. So that's what I meant when I hurriedly threw this away. Okay, so I mean, this identity, there is a lot more to these identities, but anyway, we are meeting them for the first time, and it's we have a reasonable introduction to them, I think. Yeah, what I would say is that it is not okay to. You are welcome to look up the Levi-Civita symbol, and also its properties and its deeper meaning and all that. But to simply use some result from elsewhere about what the values of epsilon ijk are is not acceptable if you are not going to derive it from the two defining properties. Yeah, you need to go that way. It's not okay, not adequate to simply state from somewhere else that uh, epsilon vanishes if two indices happen to be the same. Well, please deduce it. Okay, any question about that? Fine.
Yes, yes.
Yes,
Sir,
please. Yeah.
instead of doing this, what I did was I actually compared all the coefficients of A1, B1, C1, I mean, A1, B2, C3 with the corresponding Levi-Civita symbol. And there I compare the LHS and RHS, and therefore I say that both of them are equal.
Okay, fine. Yeah, so you are okay, you are not sure. I think I understand what you're saying. You are saying you have some way of enumerating all these terms and then identifying what the coefficients are and comparing with the corresponding statement on the left-hand side. Is that right?
Yes, sir.
Okay, okay, yeah. Yeah, as long as you've done that carefully, it's okay. Okay, fine. On the other hand, there is not too much difficulty in writing out these terms, at least in one, the first time we do it. Okay, let us now, then there was the last problem. Okay, about this acceleration of a particle moving around a circle uniformly. Okay, I am.
So do we just simply express everything in terms of I, j, k, like sine theta I, sorry, cos theta I and sine theta j, and just differentiate?
Indeed, yeah. So my position vector, well, the picture, of course, is the following. You have a particle moving around a circle counterclockwise at angular speed omega. So then its position vector r can be written as, well, I think the radius may be L, I forget. Did I say the radius is L? Yeah.
Yes,
okay.
it's L.
Yeah, so this would be L cosine omega t x plus L sine omega ty, because also the particle is starting here at time 0. Yeah. By the way, just so we understand, suppose I had not stipulated that it's starting here at time 0, but starting somewhere else. How will these expressions change, at least roughly? Could you tell me?
Just the initial phase angle will be phi.
Yeah, indeed. So the phase angle will change. And what, who said that, by the way?
Krishanu.
Krishanu, okay, sure, fine. So, yeah, so what will change is that it will become, let us suppose that the particle is not here at time 0, but here at some other time, let us say t0. Then the formula would be L cosine omega t minus t0, yeah, plus L, or sorry, x hat, and then sine omega t minus t0 y hat. Yeah, of course, my brackets supposed to contain them. Yeah, so that when t is t0, the particle will be located here. And as Krishna pointed out, this quantity is sometimes called the phase. Okay. So having got the position vector, we can immediately compute the velocity vector. Yeah, so we've done this before. So it is simply L L omega times minus sine. So minus sine omega t, and the second component would be cosine omega t. Yeah, so I've written it now as an ordered pair, yeah, just to save a little bit of space. So that's the velocity vector, and you will notice that the velocity vector is orthogonal to the position vector. This is something we had observed previously. So the position vector, of course, points this way. The velocity vector points azimuthally, counterclockwise. And you can then go a step further and compute the acceleration vector. So there we're going to get L omega squared, and we get a minus cosine omega t and another minus sine omega t. Yeah. Any question about how I did this differentiation? See, x hat and y hat don't change with time. So I can differentiate the coefficients alone with respect to time. That is the basic principle. So we notice, yes, please.
Sir, I didn't write it in general time t, sir. I just wrote it for time t equals 0. Is that fine?
Ah, you wrote the position and acceleration and so on only at time 0, is it? Okay.
Yes, sir.
Yeah. All right.
So, because I didn't see it mentioned at general time, so.
Okay. Okay. Yeah, I perhaps should have been more explicit about that. Okay. But yeah, we do. I mean, the statements we are making are valid at all times. At least the ones we were planning to make about orthogonality and so on are valid at all times. So for that reason, we would like to write it in general. So I encourage you to do that. Okay. So, and then you will notice that this expression for the acceleration is proportional to that for the position. In fact, it is equal to omega squared or minus omega squared r hat, r vector. Yeah. And therefore, we will conclude that the acceleration is centripetal. It is inward directed. Okay. Now, finally, we can compute also the jolt vector A dot. Proceeding in a similar fashion, we get L omega cubed times sine omega t, comma, minus cosine omega t. So this is the third one, or is it the fourth one? Yeah, anyway. So, and we observe that of course, A is perpendicular to V, that is also clear. And finally, A dot is in the direction of, so the sine cosine, minus sine cosine is proportional to V, yeah. So A dot is, we can write in terms of V, what is it? Omega squared minus omega squared V, is that right? Yeah, so we have concluded that and therefore A dot is perpendicular to A. So this jolt vector in fact points opposite to the velocity. Yeah, so well, what is the interpretation? Well, the interpretation of this thing is that the magnitude of the A vector,
yeah, that does not change.
Does not change with time. Yeah, very correct. Yeah. In fact, let me, since we didn't do it that way, let me also, after all, what is the statement? If I take A squared, that is the square of the magnitude of A, I want to compute its time derivative. Well, it is 2, okay, let me do it in 2 steps, d by dt of A dot A. So that is A times A dotted with A dot plus A dot dotted with A. Yeah, I'm just using the Leibniz rule of differentiation. So I must differentiate both the terms. So this is simply 2A dot A dot. Yeah, and what we have deduced separately is that this dot product is 0. And therefore, the magnitude of the A vector cannot change with time. This is also what we observed, generally speaking, also, not specifically to acceleration. Yeah, so that is the sort of one interpretation for uniform circular motion. Yeah, perhaps more can be said. Let me hold off on that. I think somebody asked earlier on for some interpretation about this jolt vector pointing oppositely to the velocity. Am I right? Could you repeat your question? Whoever asked earlier.
Yes, sir. So what is the physical interpretation of the jerk vector in this case? What role is it playing?
Okay. Okay, I let me think if I can tell some intelligible thing about that. Um, yeah, I don't. Yeah, we can cook up something. Yeah, it's possible. But let me try to do that more carefully and then answer your question. I will also say that important as it may be, the derivative of acceleration is not as important as acceleration. Okay, so and so we don't devote too much attention to it, and that is for a deeper reason. I mean, Newton's law is a second order equation, so it is the acceleration that is related to the force. The derivative of acceleration is a derived concept. It does not have a sort of independent existence. It is deduced from other things. Whereas velocity and position are even more basic, so we do pay a lot of attention to them. So the higher derivatives you can work out, but they are of lesser significance in a sense, because they can all be deduced from the earlier ones. Once you know Newton's laws and so on. So that is one reason I don't have a ready story to tell you.
Right, sir. Sir, also in your parting lines, I mean, what you said was at the end of this class that the significance of a dot a vector equal to 0 is also that the tip of the vector a would follow a circular path. So do we have to mention that as well, or?
Oh, I'm very glad you have pointed that out. Very nice geometric interpretation. Thank you so much. And if you have pointed that out, it is a very nice thing. Yeah, true. Because the magnitude doesn't change, and so it can only rotate, and therefore the locus or the tip of the A vector is a circle. That is a very nice, nice observation. Thank you. If you have mentioned it, I appreciate it very much. But which of these you give some interpretation. If you don't give all of them, it is okay. We will see when I go through the answer sheets.
But, sir, I'm very sorry, but that leads to the next question as to do we say that the jerk then actually is rotating the A vector, or do we just say that it follows a circular path, but there is no rotation per se? You see that, so that's only leading to more questions a little bit. I'm just really confused with that. Do we actually say that the jerk rotates the A vector, or do we just say that the tip of the vector follows a circular path? Because there's a subtle difference, and you had alluded to this, but because of time, you weren't able to expound on this further.
Okay. So you are asking some cause effect kind of question. You are asking me. Okay, so no, okay. All right. So you're asking me whether it would be correct to say that the jerk vector is causing the A vector to rotate in a circle.
Yes, sir, precisely.
Okay. So mathematically, it is basically true. After all, the rate of change of A will tell you how A changes, and so to that extent, it's all right. But yeah, I hesitate to say that as a physical statement because the cause of these things is neither A nor V nor X or A dot. The cause of all these things are coming from some force somewhere else, yeah, which we have not yet discussed. Yeah, so yeah, one can address this question in different ways. If you ask a particle, why does a particle move this way? You can give the answer because the velocity points this way. And that is okay, but it doesn't address the question about what are the physical causes for that. Yeah, and those are coming from the force. So it is that distinction I would like to make. Yeah.
Yes, thank you.
Yeah. If that was of any use to you. You can always ascribe the dynamics of a vector to that of its time derivative. Now, this is a little bit of a game. I don't know how much utility it has. Okay, I have unfortunately run out of time. So we shall continue our discussion of polar coordinates next time. Anyway, I think it has been valuable for us to discuss all these problems. And I appreciate your having tried all the problems. Any questions remaining now?
Yes, sir. In the last question, actually, I derived V and A and A dot in terms of polar vectors and then converted it in terms of X and Y.
Okay, so you are one step ahead of us. That's okay.
SL coordinate geometry, that is some portions on polar coordinate equations of circle, line, and conic. Should we read them before next?
Okay. No, see, sorry, I would need to look at your answer sheet to really understand what you have done. Briefly.
No. About polar, so you were telling next day you will start polar coordinates. And can you recommend some good books on the or in general coordinate geometry or paper?
Okay. Let me try to say something. I don't have a, see, the books I mentioned already would have some elementary things. Yeah, so when I say polar coordinates, I am talking specifically here with regard to plane polar coordinates, cylindrical coordinates, spherical polar coordinates. So we will introduce them in some way already, and also to the next class. Based on that, maybe you can ask your question again, which aspect you wish to study more about. Yeah, or if I can suggest some place you can read more about them. Okay, so that was Shubham, was it? Sorry, who asked? Okay, Dviti Maya, perhaps.
Yes, sir. I had asked about the polar one. Yeah.
Yeah. So do I understand? No, please repeat your question.
No, I just said that I did the derivatives in terms of polar and then converted it into I cap, J cap, K cap.
Okay, I am amused to hear that because, we have not yet discussed polar coordinates in so much detail that, but if you are able to do it, well and good. So fine, we will have a look at what you have done. Okay, any other queries?
Sir, one small thing not related to this question. I may have forgotten to mention my roll number and I then mentioned it afterwards in the comments.
Okay, fine. All right. Okay. Yeah. So Anhad asked when will we study Newton's laws? Yeah, that's coming up. I hope sooner rather than later. I hope next week we can do some of that. Yeah. So
sir, a question related to this answer that a dot is equal to minus omega square v. So a dot is v dot dot, right?
Yes. Second derivative of v. Yeah.
V dot dot is equal to minus omega square v. As someone other than me pointed out in the group, this can be thought of as simple harmonic motion. Yeah. So first question is that whether this would be a good answer to the question, what is the significance of a dot is perpendicular to a? And the second question is like, can it be really called a simple harmonic motion?
Okay. Yeah, that is a nice observation. You are quite right. So you are saying that the A, did I hear you right? That A, did you say A dot dot or what did you say?
V dot dot is equal to minus omega square v.
Fine. Yeah. A double dot is minus omega squared A. Yeah, that is the equation for a simple harmonic motion, vector version. That is correct. So if you have mentioned that, that is also a nice observation. But that is not okay. No, I am willing to take that. And uniform circular motion is a realization of simple harmonic motion in a sense. Yeah, there is meaning to that statement.
Thank you, sir. It was not me who mentioned that. I think somebody else.
Okay. Fine. Yeah. Fine. So So in the case of uniform circular motion, there is a kind of hierarchy of these successive derivatives. The story kind of repeats itself if you go to two derivatives further. Anyway, not a big deal.
Sir, on a more practical note, what kind of problems do we focus on? Because the problems that you're asking have a very theoretical flavor, but the problems in Lebanon are very applied.
So you can focus on the problems for the answer sheet which we are discussing, and you are welcome to supplement that with some things from the book, which you, as you point out, have a more applied feel. Yeah, no, okay. I think our course is a little bit more conceptually oriented than some of the contents in the book. I agree with that. It is partly because of the background of students, my own biases, and what that we have a very significant mathematically oriented audience. It is partly done for that reason.
Sir, one question,
Yeah.
please. Sir, I want to know that whether we will be studying in classical mechanics, and whether we will be studying Lagrangian mechanics and Hamiltonian mechanics also.
Yeah, that is very much a part of classical mechanics. Whether it will be in this course, I am not sure. That is supposedly in the next course, Classical Mechanics 2. Yeah, but let us see. Based on the situation, we will decide. I must say that the first few lectures are not really about the dynamics of classical dynamics. We are just discussing some kinematics and a little bit of mathematical preliminaries, just to have a common language and understanding of things. This is not full-fledged physics, and that is partly why the problems may look a little bit more theoretically oriented, or whatever word you used, rather than more applied. Yeah, so we are not yet into the core of the subject. Yeah, any other questions? Okay, if not, thank you for your attention, and we will meet next Tuesday. Have a good afternoon.